Now that we spent some time looking at the standard normal curve, now we're going to look and see what if there's a real scenario we can connect it to, a distribution that is normally distributed, so now we can actually take real data. So the question is, how are we going to connect this to the standard normal curve? Well, the first thing we're going to have to do is we're going to have to find that standard score. So we're going to have to use the mean, the standard deviation, and the value to find the z-score, or the standard score. Once we find this, now we'll be able to use our curve and use our Inspire calculator, because now we're at one curve. We're back to that standard curve because everything is now based on a standard score. So instead of looking at a score of, let's say, an 86 on a test, we're looking at being 1.31 deviations above the mean. Now the question is, how are we going to tie it to percentiles? Well, by figuring out the area to the left of your score, that will tell you what percentile you fall into. So for example, if we know that the area from your score, which we'll say is right here, if the area to the left of that is, let's say, 0.86, this person falls into the 86th percentile because 86% of the fellow classmates fell below that particular score. So let's look at an example of this. The hourly wage of a secretary in a large nationwide corporation is known to be normally distributed with a mean of $11.39 and a standard deviation of 98 cents. So now we're looking, what is the probability that one randomly selected secretary will have an hourly wage, and they give us different scenarios there. So the first one, we're talking about more than $12.25. Then we're talking about less than $11.25. And then we're talking about between $11.25 and $12.25. So the first thing we're going to do is mark everything down, and we need to find the z-score for $12.25. So what I want you to do is pause the video for a second and find the z-score for $12.25, and I want you to find it for $11.25, and then we'll go from there. So now that we have our two z-scores, what we want to do is go to our graphing calculator and plug them in. The first thing I'm going to suggest is actually drawing a curve to represent these scenarios. So scenario A, we're looking at 0.88, and we're looking at the area above that number, because remember, this is our standard score, so that's the number that's going to go right there. The second one, we're looking at area that is to the left or smaller than negative 0.144. And then the last one, we're actually looking for the area that is going to be between those two z-scores. So what you're going to do now is the same thing that we did yesterday. You're just going to go to your graphing calculator. For the first one, you're going to do your normal CDF. Your minimum is going to be positive 0.88, with your maximum being infinity or a large number. And you're going to find your area under the curve. And for that one, you're going to find 0.19 being the area of this right here. So that tells us that the probability of a secretary earning more than $12.25 per hour is about 0.19. Well, I'm going to do the same thing for those secretaries that earn less than $11.25. We found our standard score to be negative 0.14. We go to put that in, but we're looking less than, so our minimum is going to be negative infinity. Our maximum is going to be the negative 0.14 standard score. When I put all that in, I'm going to end up with an area or a probability of about 0.44. Which tells us that the probability of a secretary earning less than $11.25 is about 0.44. And then for our last one, we would just take those two numbers, the negative 0.144 and the 0.88, plug them in as your minimum and your maximum, put those into the calculator, and that's going to find you an area between of 0.37. So let's look at an example where we have the percentage or we have the probability and we're trying to work backwards. So now in this scenario, we're still dealing with the secretaries from before. So we still have the exact same mean and the exact same standard deviation. So let's put them down. And now we're going to focus on that inverse norm that we talked about yesterday. So the first thing we're going to do is we're going to look at the bottom 20% secretaries. So when we draw our curve, we're talking about 20% being to the left. We're going to go to our inverse norm. We're going to put that in as our area. And that's going to give us a standard score of negative 0.84. And remember, this number, negative 0.84, is coming directly from my inverse norm, my calculator. So now I'm going to go to my formula, my z-score, my standard formula. I'm going to plug in that negative 0.84, but I'm going to use the manipulated formula for this one, where I'm actually going to use this number, because this tells us how many deviations below we are. So go ahead and watch how I set this up. So now that I have this, all I want to do is algebraically manipulate this. Multiply both sides by 0.98, and that will give me, and then once I simply add $11.39 to both sides, that's going to give me a value of $10.57. So that tells me that the maximum hourly wage for the bottom 20% of secretaries is going to be $10.57. So what I want you to do is pause the video for a second. I want you to try and do it with the top 10%, but keep in mind that we're talking about 90% being to the left. And ask yourself, how's that going to affect you when it comes to what I put into my inverse norm? So go ahead, pause the video and do that, and I'll have all the work for you in a second. So we find the 1.28 for my z-score, my standard score. We multiply both sides by 0.98, which gives us $1.25 on the left. Once we add $11.39 to both sides, we find the minimum hourly wage for the top 10% of secretaries is going to be $12.64. Well, let's look at the middle 30%. That's going to be a little bit different, but not any harder. So now if we're looking at the middle 30%, we have to figure, well, if this is 30% in the middle, that means there's 70% cut off the sides, which means both sides, since it's split evenly because it's symmetric, have to have a probability of 0.35. That's the number I'm going to use when I put this in the inverse norm, and that's what we'll pick up class tomorrow. So what you actually do is finish this out. I'm going to leave the question for you, and this is where we'll start class.